Imagine standing at the edge of a supermassive black hole, its gravitational pull so powerful that it warps time and space around it. What if I told you that just a few minutes near this black hole could equate to years, decades, or even centuries on Earth? Welcome to the mind-bending world of black holes and time dilation. Let's dive into how time behaves near these cosmic giants and what it could mean for the future of space travel. A supermassive black hole like the one at the center of our galaxy, Sagittarius A*, is millions, if not billions, of times more massive than our Sun. These black holes are so dense that they bend spacetime in unimaginable ways, creating effects that stretch beyond anything we experience on Earth. Time, in particular, behaves very differently near one of these black holes. The phenomenon we're talking about is called gravitational time dilation, a strange but real consequence of Einstein's theory of general relativity. Essentially, the stronger the gravitational field, the slower time passes. Near a supermassive black hole, this effect becomes extreme. Imagine orbiting a black hole, where minutes pass normally for you, but centuries fly by on Earth. The world you left behind would be unrecognizable upon your return. To you, everything might seem normal. You'd experience time like you always have, but for observers far away, say, on Earth, time would appear to be moving much faster. A few minutes of time for you could stretch into years, decades, or even centuries for someone far away from the black hole's influence. In fact, if you spent just 1 hour near a supermassive black hole, 100 years could pass on Earth. That means you could leave in 2025 and return in 2125. So why does this happen? It's all about gravity. A supermassive black hole's gravitational pull is so intense that it distorts the fabric of space-time. The closer you get to the black hole, the more time slows down relative to the rest of the universe. If you were to venture close enough, even though only a few minutes would pass for you, when you return to Earth, you could find that hundreds of years have gone by. Think about it. What would it be like to travel to a black hole and return to Earth only to find that centuries had passed? The world you left behind would be completely different. Technologies might have evolved, civilizations could have risen and fallen, and people you knew could be long gone. This concept isn't just science fiction, it's grounded in real physics. The extreme time dilation near black holes has been tested and confirmed by experiments with atomic clocks. In fact, time dilation effects have been observed even near smaller objects like planets or satellites, though they are much less extreme than what you'd experience near a supermassive black hole. But here's the thing, traveling so close to a supermassive black hole isn't something we can do right now. The closest black hole to Earth, known as a 062000, is still thousands of light years away. And even if we could somehow get there, the journey itself would be a huge challenge. Venturing too close to the event horizon would mean being stretched into spaghetti-like strands by the black hole's immense gravity, a process called spaghettification. The gravitational forces near the event horizon would be intense, and anything that ventures too close to the black hole is inevitably pulled in. But the fact that such bizarre effects exist within the universe opens up incredible possibilities for the future of space exploration. Imagine using a supermassive black hole as a time machine, where a trip near it could send you thousands of years into the future, all while only a few minutes or hours pass for you. While this idea is currently just a theoretical curiosity, it shows just how strange and fascinating the universe can be. Time dilation near a supermassive black hole forces us to confront fundamental questions about the nature of time, space, and the limits of human exploration. What happens when you travel close to a force so immense that the rules of reality bend? Could we one day harness this effect for our own benefit? It certainly opens up possibilities for space travel, though with immense dangers along the way. So, what do you think? Could time travel become a reality just by visiting a supermassive black hole? If you could travel to a black hole and return to a future Earth, would you do it, even if it meant leaving everyone you know behind? Let me know your thoughts in the comments below, and don't forget to hit subscribe to stay tuned to the universe.